Good afternoon. Welcome to today's Liftoff webinar brought to you by LIFT, the National Advanced Materials and Manufacturing Innovation Institute, where we drive American manufacturing into the future through technology and talent development. LIFT is a public-private partnership where we convene and connect government, industry, and academia in the fields of advanced materials, manufacturing processes, systems engineering to enhance America's manufacturing competitiveness, national economy, and national security. My name is Christine Longworry, Senior Director of Industrial Base Engagement. And today it's my honor to introduce our presentation by Kevin Kerwin, CEO and President of Detected AI, where he will be presenting improving quality and vision systems with AI software. His presentation is going to focus on the needs of AI to assist with the improvements in quality inspection, visual detection, and manufacturing, and how the detected software can be utilized for this purpose. So welcome, everybody. Thank you for joining us. Kevin, take it away. Appreciate you being here today.
Thank you, Christine, very much for the humble intro. Good afternoon, everybody. I appreciate you taking the time to join me today. I may know a few of you out there, and for those that don't know me, I'm a pretty hyper person, so I will try to slow things down a bit. And I'm not much of a PowerPoint guy as an engineer, but I will do a nice PowerPoint, and we'll continue through that. So thank you again today. I'm Kevin Kerwin, the founder and leader of Detected AI, where we're taking the power of neural net technology for visual detection out of the sky, the cloud guys' hands, out of the coders' hands, and getting it into the hands of engineers in the form of an engineering tool so they can solve quality-related visual detection issues that previously basically were not solvable other than fully automating quality into the process at great expense or putting people on it and praying. And I'll be honest with you, putting people on it and praying is not a strategy, although it's used extensively throughout the manufacturing industry. So today we will talk a little bit about, I'll give you a little history of who I am, where I came from, why I made this technology. So I'm a serial entrepreneur. My dad was a controls engineer in the 70s. My mom was a bookkeeper. 1977 comes around. I'm 11 years old. We bust out and started a controls engineering firm. So basically, I'm washing drafting boards, running blueprints, and cleaning toilets. Today, I just do the toilets, no more blueprints, no more drafting boards. But point is I was born into the infancy of Industry 3.0 when it was just in its beginnings, and I got to witness the whole maturation cycle of automation as we know it today, Industry 3.0, and then the entrenchment and beginnings of Industry 4.0. So I have a lot of experience as a systems integrator, controls, vision guy, as an entrepreneur. I exited successfully one of my last businesses, International Wheel and Tire. I was too young to retire. I don't really want to retire anyways. I don't golf well. I don't really want to golf well. I like creating things. And I saw a big gap in our market of manufacturing for visual detection where it was not being addressed by the industry giants that own all the visual detection that is currently in most of your manufacturing plants. So I created a company. We started writing code in 2018. We found our brand and name in 2020, created the company in the end of 2020 to bring the power of this technology, get it into the hands of the engineering community. So the problem remains. Manufacturing quality is still an issue. We spend lots of money. Every one of you out there has got processes in place to try to catch bad parts, whether you're automating it, whether you're using polka yoke systems, whether you're putting people on and praying. You have processes that are in place and have been in place or currently being put in place to catch bad parts, but basically bad parts are still getting out. You spend all this money, but then you still get dinged with quality issues from your customer. How is it that we still exist? Is it a lack of capital to fully automate? Automation is expensive. Manual processes, and we have lots of them, are prone to error. To err is human. I mean, that's all I can say. Nobody is going to be a perfect operator or a quality inspector. There are currently substandard quality inspection systems. The word machine vision usually is a four-letter word in the manufacturing processes these days because most of them are in bypass. We also suffer now from a high amount of assembly worker churn. I can't get the same people twice. Training's never like what we would like to say it is. And then occasionally you get somebody that has a burr in their boo and they're going to show the man who's boss for the day and make some bad parts. The old Coke bottle in the door panel trick back in the day. So I saw a need for this technology for AI-based visual inspection um, to come to the manufacturing market to be used to offset, because the current industry giants, your Cognexes, your Keyences, your Matroxes, your Teledyne, Delsa, Basler, Sick, Banner, I don't care, you name them all, I programmed them all. They are not telling you the truth about what this technology can do. Yes, they have AI in their products, but it's not the kind of AI that I'm bringing. And the reason they can't tell you the truth is because they make cameras. And in my world, the camera can be anything from a security camera for $105, a borescope for $50. You can buy a little machine vision looking camera cube thing for $400. The most expensive camera that I would recommend to you, and all of this can be bought on Amazon, is a $1,600 pan tilt zoom camera that you'll see how we use in a little bit. To solve multiple inspection points where you have to inspect multiple things and you would need multiple fixed cameras to do it. You can use, basically, I don't know if somebody can see, but pan tilt zoom camera, 4K, 60 frames a second. So the camera is an accoutrement. It is whatever you need to get a view of the item defect process that you're trying to do visual detection with. Cognex, Keyence, and all the industry giants that own the machine vision market today, their camera starts at $2,000, and that won't even do the job. So now you're talking about 4, 6, or 8, or 28,000 for their cameras. So they make cameras. They have to sell hardware. They can't tell you that the hardware doesn't matter. So big problem there. And you have Google, Microsoft, Amazon. They understand this technology, but they don't understand our manufacturing market, and they offer a cloud to edge solution or a software as a service solution. And that doesn't fly in the manufacturing environments I grew up in. Nobody's going to allow an outside connection to the plant floor. So I contend that there's a gap in the market that our technology is going to fill, because the current industry giants are not going to tell you the truth. So humans make mistakes. Most of all of our errors that come back to us from your customer, return the part, this is not right, it was bad, comes from people. As I said, to err is human. It's just the way we're built. I'm sorry, we don't like to make mistakes. Nobody likes to talk about the mistakes, but they happen. So 23% of unplanned downtime, the most expensive thing you have in a manufacturing environment, cost-wise, is unplanned downtime. It's caused by people making mistakes. Everybody has a good realization that there's room for improvement. 45%, that's kind of BS in my world. I think 90% of people think they can improve. They don't like to admit it. They won't publicly state it, but they know they got room for improvement. And over the span of, I don't even know, 3 years, at least everybody has had unplanned downtime. And this could be from assembly mistakes. It could be from process mistakes. It's just humans. I'm sorry. This cost of quality is expensive. I spoke before about all the money you currently spend to try to keep bad parts from getting out. But take a look at the cost when it comes back to you from your customer. People spend a lot of money on making sure you didn't send parts. Then bad parts come back. Then the customer's mad at you. You don't send them a check for the bad part. They deduct the amount of the bad part from your monthly atonement. So you can arbitrate it later with them, but the bad parts are costing you money. And then if you do too many, they put you in containment where you have to have multiple inspectors, and then you have to pay for a third-party inspector. This is expensive and it's painful, and it hits the bottom line directly on the profitability of a plant or a division. I mean, Ford spent, 1.4 point something billion on warranty payments that were basically quality issues that made it out to the customers' vehicles, and came back to dealers. So the cost of this poor quality, is tremendously expensive, and sometimes it's not easily quantifiable, but everybody knows what it feels like and what it's like to have these problems. So the problem, why do we have bad parts getting out the door? All right, the reason I believe is the current way we process our automation or design a line is somewhat like this layout here. I'll speak from the viewpoint of a tier one, a major tier one provider to, let's say, one of the OE car companies. These tier ones get a new program. They get X amount of money for that program. They develop tooling and a production line to process the parts for that program. What they'll do is they'll spend the money on automation for the critical stuff so they can sleep at night and not worry about it. But they don't have enough money. Programs are too short. Customers don't have enough money to spend, so they can't automate everything. So then you're back to putting people on it. So you automate what you can afford to automate so you can sleep at night. You put people on the rest of it because people are basically cheap. And you poke a yoke or error proof it at the end of the line, hoping to catch any mistakes that the people might have made during assembly. Unfortunately, if you did catch them, you've already built the part up halfway. But a lot of the times, these error-proofing systems are in bypass. They're the existing gamut of machine vision company stuff that doesn't work well, that's very non-tolerant to environmental condition shifts. So the systems are in bypass, and we still have somebody looking at the part downstream before it bags out going to the customer. So all of the systems that you bought and spent rely on the last person at Op 70 to catch everything. And this is the way it is in a lot of places. Now, when the vice president of the company comes walking through, the person at Op 70 is not there. The error proofing systems are all turned on, and everyone's told to make sure the parts are all good going through the error proofing system. And then as soon as the vice president walks past and gets out of the plant, the error proofing goes into bypass. Charlie comes back to Op 70, and the work continues again just as it was yesterday, and bad parts get out the door. So back up. So what's the solution? We spend all this money, we still get parts going out the door. You can't automate your way out of it because you don't have enough money. Everything else has been tried. I mean, we have lean manufacturing. We went through all of that. We've got all these other systems we've bought and tried, and all of it's not working. Bad parts are still coming back. And I'm praying that Peter catches the bad parts before they get out the door, back to humans again. So the answer really is to deploy true neural network-based visual detection AI to do the work that humans do. It's basically human level vision without the mistakes. Now, the one key factor is that it needs to be running in live video. You can't be taking a picture at a moment in time and then trusting nothing changed after that picture was taken. It all needs to run live in video, just as if a human was watching it, but without the mistakes that we make, right? So this technology is fast, it's reliable, it's accurate, it's very accurate. I mean, people debate on human inspector accuracies. Most of the time they argue if it's 95 or 85% accurate to have humans inspecting parts, even with double inspectors. But this stuff is up in the 99.9 accuracy without making mistakes. Our system that we developed uses off-the-shelf hardware from Amazon, Google, or Amazon, anything you can buy online for cameras most of the time. Unfortunately, we cannot use the existing machine vision cameras that you may have already in bypass on your line because they're closed. They're not open protocol. They won't work with our software. They won't work with anything but their own manufacturer's software. So you're stuck in that, but you can simply replace those cameras with off-the-shelf affordable security grade cameras. So we are fast and easy to use. And the most important thing, I think, is that we are not cloud-based. We are all on-prem. There is no internet connection required. So I am secure. I don't have, people ask me, what are you doing about cybersecurity? My answer is I'm not attached to the internet, so I don't really have to worry about it. We're highly reliable and high speed, fast. We can process upwards of 350 frames per second if we need to. Most of the time we don't. So if you were to reprocess a new line, get a new order for a customer, and you're going to design your manufacturing line, I suggest you look at designing it like this as opposed to the design we looked at a few slides back. My contention is you only need to automate what is too heavy or dangerous for us to do. Humans are the most dexterous robots. We're the fastest, the quickest, in theory, the cheapest in certain respects, because so use people to do this work, but then put a camera at every station, a simple $100, $200 camera at every station, and use that camera to make sure that the operator assembled the parts right in station, not allowing bad parts to get down the line. There's no sense in checking at the end of the line for bad parts because you've already added more parts to the bad part that you have to unassemble to fix the bad part. So no faults forward. So if you go with an architecture where you have a camera at every station, making sure operators can't mess up the parts, no faults forward, your first time through metrics go right through the roof. I mean, they're in the high 90s for first time through without rework because there's no reworks getting past the station. So use simple cameras to help people do their job. Nobody likes to make mistakes. No one wants to talk to somebody about a mistake. Just have something there that doesn't inhibit my work, doesn't impede me, but checks to make sure I did the job right so that I can't get the job out of my station wrong, so that I don't have somebody harping on me. Don't harp on the employees, help them. This technology is here to help us. So I contend that the technology that I'm bringing to the market is like Rosie the robot on the Jetsons. She was there to get us off of jobs that were bad for us, like cooking. I don't like cooking. I don't like cleaning. I don't want to have to look at parts all day to make sure they're correct. Chalk mark, check this, check that, check this, check that. It's a bad job for us. We make mistakes. We miss stuff. So get me off of those jobs. And then, like Rosie the Robots on the Jetson, where you will always have people help those people with the higher level functions like getting my jacket on or assembling parts. So use this technology to get people off of bad jobs and help people do the good jobs correctly so they can't make mistakes. There's a lot of nebulous thoughts or myths, if you would call it, about AI in manufacturing. As engineers, we are not often plugged into the AI world like coders would be. We use our engineering tools, program robots, program PLCs, do digital twins, do simulations. We use that stuff all day long, but most engineers don't know a lot about the intricate workings of artificial intelligence. They only know basically what they've been told by the salespeople of the existing cameras like Cognex, Keyence, Teledyne, Delsa, Baszler, because their salespeople are telling them they've got AI in their camera now and it can do this and it can be used for that. But most of those camera companies only want the customer to use the AI model for specific high-end applications and to use the regular bevy of all their regular rules and tools-based cameras for 90% of the work. That's a big myth. That's not true, but that's what the industry tells the engineers. So the engineers don't really know. And then they think, oh, it's going to be super expensive. I'm going to need data scientists. I'm going to need some consultant. It's hard and it's complex to customize. I may need to know how to code something. And then they have reliability and security issues because the people maybe from Amazon or from Google or from Microsoft that are also talking to these engineers, trying to educate them about this technology, are offering cloud-based solutions. And the engineers and the IT people in the plants are like, listen, we can't really have cloud solutions in our plant, blah, 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 blah. Now, I know some of these companies store data on the cloud. They gather all this data to their local servers, and then they push it up to the cloud for storage. But to have the cloud make a decision that this part is going to go forward as a good part or this part is going to go sideways as a bad part, that's just not going to happen. So the cloud, the engineers get reluctant because they don't understand it. Nobody's telling them the real truth about it. Some of the engineers know because they're half coders, but they again think they have to code the applications. So there's a lot of myths that I had to get through with the engineering community to get over that hump to start with. And it was all about reliability, security, how easy is it? I don't know anything about AI. I'm not a coder. So there's a fair amount of myths that has to be cleared up that I'm going through and teaching people basically. So the reality is that detected software basically obfuscates all of that from you. We are an engineering tool. If you can basically take a video, draw a box, and give a name to that box as to what that item is, then you can start training neural nets. I make a joke and say it's for ages 9 and up, but because I actually have the Girl Scouts come in here to get their technology badge, so we have them train neural nets on their cookies. Like, is it a Thin Mint? Is it a Tag Along? Is it a Samoa? And they have a blast with that. But I got 9-year-old Girl Scouts teaching neural networks how to identify cookies. So at that point, your engineers are more than skilled enough to use our technology to develop stuff. I designed this stuff specifically for the rigors of high volume, high speed manufacturing at the plant level. It's purpose built for you. I lived in your shoes. I want to give you the truth. We have separate modules for each stage of the development. So if you wanted to, you could bust the workflow up to only certain people can collect data, only certain people can label it, only certain people can train it. But my experience has been that most of my customers just assign one person to be the head of their AI deployments, and that person does all of the workflow steps. We're fast and easy. Literally, you can have an AI detection, visual detection net up and running in a couple hours. Gather a video, label the data. We automated the labeling process to make it very fast and easy. Do the deep learning, deploy the net and run it. And literally in a couple hours, you'll be running stuff that you couldn't have easily done in days with the other people's technology. And again, as I said before, I built this for reliability. We write everything in C++ to be as fast as possible to run and also be operating system independent. Although most of my customers run Windows, we do support the Linux. But our technology is fast and easy, and it's designed to run on your plant floor with off-the-shelf consumer-grade computer hardware. So again, it lets anybody harness the power of AI. The Girl Scouts, you engineers, easy, no coding, don't have to understand. You don't even care that I wrote it in C++, but it means that it's fast, reliable, and easily deployable. It's AI for everyone, really. What are some of the advantages that I bring. And that's a pan tilt zoom camera right there that you can program 255 positions to look at stuff on parts. So we don't need stop stations. I don't need fixturing. I'm video based. As soon as that part starts transferring into my field of view, I'm going to start detecting. We are super fast. As I said, we can run upwards of 300 frames a second. Most of the time, my customers are running 30 frames a second or slower. We automated one of the pain points of neural networks, and that is labeling the data for your deep learning. We've automated that, makes it very fast. And again, we're on-prem, behind your firewalls, no clouds, no cybersecurity issues. The advantages of a video-based AI system. There are AI systems out there by others. They're picture-based. Take a picture, analyze the picture, and that works. But really, you need video, because I would like to have the full field of view. I want to detect that part as it's entering the field of view. I don't want to have a trigger or stop the part. I don't want to have to worry that after the operator assembled the part right and hit a button to take a picture to make sure it's right, that they unassembled something after the picture was taken, because if they have malicious intent, they will do that. So we get used for a lot of things that are not quality related. We're a video-based AI detection platform. I don't care what you want to detect. Yes, most people use us for quality, assembly quality, or defect detection, things like that. But people use us for inventory control. People use us for automated material robots, delivery of them. People use us to monitor fork truck traffic. People use us to monitor, HR in one of the plants is counting heads in the smoking lounge. Now, I don't have any facial recognition software built in. I don't plan on it, but your head, I can teach your head or her head or anybody's head, because we, as humans, we don't do facial recognition. We just look at each other and go, well, that's Peter, and that's Susie, and that's John, and that's Paula. So that's how we work. Our technology is the same. So there's a lot of people use us for PPE, a lot of stuff, inventory. I'll show you some examples. But there's a lot of advantages to video-based AI that you can take advantage of. Our solution, as I showed you a line layout before, but we have two software packages. The development environment, is called Net Builder. It's up here. It's in plant engineering. Your engineer has it on their laptop. Net Builder is what you use to develop your neural nets and test them and make sure they work right. And when they work right, you can't run the plant with your laptop. So you deploy the neural net to a local computer that's down on the manufacturing floor, and that reads the cameras, talks to PLCs, talks to MES systems, and you can do it again for line 2, line 3, line 4. We kind of call this a local approach from an architecture standpoint, because the computer that is running the neural net is on the plant floor, so it's local to the cameras. Many of my customers use this architecture, but many of my bigger customers segue to what I call network architecture. I'll show you, it's a little further down in slides. But basically, we have Net Builder and Net Runner. Builder's your development environment. It's your AutoCAD. It's your SolidWorks. It's what you use to develop everything. And Runner is the runtime environment that runs it, talks to PLCs, talks to MES, reads cameras, warns operators. Our development environment is very easy to use. Net Builder, you basically collect videos to a project. So go into the collector module, add a new project, collect some videos from your camera to that project, then come back out, go to the next step, labeler, where you go into those videos and you draw boxes around specific things that you want the neural net to learn. Like, this thing is called an electrical clip, and that is open, and here's what it looks like when it's closed. So you draw boxes around stuff, good, bad, correct, incorrect, low, high, whatever you want to call those things. You draw your boxes around those in the video. Then you come back out, do deep learning, train the neural net in deep learning. And basically, deep learning is nothing more than playing flashcards. Like if you ever learn the ABCs, you got A, B, C, D, E flashcards. You play this game, going through the deck with your kid a bunch of times till they get it right. You shuffle the deck until they get it right, and they get it right a bunch of times. And then after that, they know 26 things. And you throw the flashcards away, your kid now has 26 items trained in their neural network. It's basically the same thing. You deploy the neural net, and then you run the neural net. So it's very easy. Collect video, draw boxes, train the net, deploy it, and run it. Here's a case study. Magna is one of my largest accounts. We're in 38 of their exteriors plants across North America now, ranging from Toronto down to Saltillo. We're also in the seating plants, and we're getting into their metals Cosma division. But basically, we replaced Amazon Greengrass as the new standard. They were going to go with Amazon Greengrass, but they didn't like the cloud solution. They didn't know what else to go with. They found us after a little bit of thumb wrestling per se. They chose us over Amazon for all of their plants. And then Magna also did something interesting where they set up a center of excellence in their Highland Park plant, where they have a team that is the detected team that can go to any plant and deploy the technology or help their plants. And also they are the ones that are, the keepers of the neural net. So if I got a neural net that recognizes defects on a surface, and I got plant 1, plant 2, plant 3, plant 4, I don't want to do that same work 4 times. I'm going to teach it on 1 plant, and then I'm going to deploy it in 4 plants. That's what their team in Highland Park does for them. Here's again what I spoke about, a local approach where the computer that runs the neural net is on the plant floor in areas 1, 2, 3, 4, wherever. But most of my bigger customers don't like all these little computers scattered around the plant floor. So they do a network approach where they install a video LAN in the plant, and they bring all these cameras wherever they are in the plant back to the server room, and they use server grade hardware that can run many cameras and still talk to PLCs and still talk to MES systems. It's really no different than the local approach, other than the fact that the computer is a much more powerful computer and it is sitting in the IT closet, not on the plant floor. So local approach, network approach, either one. You can do both. You can blend them. We don't care. Some of our customers, again, when I came out with this technology, the tier ones are looking for people like us. Although we do now have General Motors and Honda on board, but the tier ones were the first people to start gobbling me up, helping them learn more. Now, I will. I'm going to go through a video or two just to show you some applications, and then I'm going to open it up for questions. So give me un momento, por favor. So a lot of people use us for operator assembly. And I'll just show you one. This is a motorcycle gooseneck for, I believe, Harley Davidson. And I can verify that everything is being installed. I'll just skip through a little faster. You don't need to see everything. You get the point. I can see those bushings have been pushed down. I can see certain nuts have been installed. I can see where the operator's holding a torque wrench. Make sure they tighten bolts. So a lot of people use me for spatial tool. What bolt does the operator have the torque wrench on for that? Because I can be used for anything you can see. Our only rule of thumb for detection is you have to be able to see it on a monitor. And if you can see it on a monitor, you could teach someone to sit at that monitor to detect something, then you can teach detective to detect it. I don't care what it is. Here again, let's help operators. So you can see this person has earbuds on. Operators are not engaged. They're thinking about last night. They're thinking about tonight. They're listening to music. They're talking to their girlfriend. I don't know, but they're not paying attention. They're just going through the motions. And we're not going to have like kumbaya training to get them all on board for paying more attention every day. It's just not going to work. So just help these people be less engaged and not make mistakes. I have UAW lines asking when we're getting detected on our line. They got it on their line over there, and we want it on our line. And the only reason they want it is because it allows them to be less engaged with the overall process and not make mistakes. That's basically what they're after. I have another one, Carhartt label stitching. They're asking the operators to stitch these caps in the label, and they're asking the operator to check the sewing machine because the sewing machine screws up and misses stitches. Now, you would go crazy looking at this stuff all day long, little white stitches on white caps. It's not a good job for us. So we simply stuck a boroscope, a $70 boroscope, on the sewing machine. The operator pulls the hat back after it's finished sewing to a check position, and we say it's a good hat or a bad hat. This is another one. All these car parts have a million pieces on the back side of them. And we need to make sure stuff is assembled right on the back side. This is a fascia. Let's say something's not assembled right on this, or it's not clicked down. That's electrical connectors. It'll pass continuity. It'll get out of the plant. You'll be driving your brand new car, and in 2 months, you'll start getting some sort of sensor warning. And now you got to go to the dealer, and they have to pull your whole fascia off to fix this thing. God only knows what they screwed up when they pulled the fascia off to fix your other mistakes. So a lot of my customers used us to verify that parts are assembled right. This is another one, laser welds. The laser welder screws up, and they got people looking at all these welds to make sure these welds are good before the seat frame, it's a seat frame, gets packed out for shipment to their customer, and they miss stuff. So, you got bad welds, porosity, blow through, things like that, defects. But they're using people to do it. Here's another guy in the seat plant for furniture seats banging T-nuts into the seat. So the problem is if this operator misses a T-nut in the seat, this is the bottom, then the thing goes to assembly. They put the foam on, they put the leather on, everything's fine. They get it to put the pedestal on it, and they can't put the pedestal on because they're missing the T-nut in the bottom of the seat. Now they got to unassemble the whole thing, take the leather off, take the padding off, put another T-nut in. Let's just verify that the operator didn't miss something right at the station. This is another one here. Operator is cleaning glass, basically. What they're supposed to do is apply an alcohol wipe to the glass. The problem is the alcohol dauber goes dry and doesn't apply, and the operator is just going through the motions, not paying attention to the alcohol that is dry, and they're actually not cleaning the glass. So they have to prep the glass with an alcohol primer and a bingo dauber, and then they have to put the paint on itself with another bingo dauber. So we're checking the paint quality and the bead of it, and we're checking that the alcohol wasn't dry. It was leaving a sheen behind the dauber. If it's not leaving a sheen or there's gaps, we stop the press, tell the operator. We also get used for inventory. So people use us to look at shelves for Kanban, right? It's not quality, it's inventory control, a visual Kanban. Are these bins low or medium or full? Do I need to call for more materials? There's a lot of Kanban systems in the plant, material replenishment systems. They all get used by a button. The operator has to press a button to say, give me more of this and give me more of that and give me more of this. And believe me, operators play games with when they press buttons. So I'll play one more video, and then I'm going to open it up for some questions. People use me for AMRs. This is an AMR. It's a material tugger. It tugs material around the plant, this little yellow thing. The issue is they need to know when to send a tugger to a cell. How does the person initiate a call to have the tugger come to a cell? This is a simple security camera, $150 bubble cam sitting 24 foot up off the ceiling, and I can see what's going on. I can see if the cell is full. I can see if it's empty. I can see if there's only a cart or a pallet. But this company uses us in various different ways to elicit calls to their tugger to have it come deliver materials to some area or zone. Just for the fun of it, I know you all work in factories, and I'll show you this one. This is a dirty factory. If you ever looked at a dirty factory, this is dirty. So this is a cement dust manufacturer in Alpena, Michigan. They make the cement dust powder. And look at it. The problem is that their furnace that makes the powder has a problem, and it starts blowing plumes of dust out. We train neural net to detect when the plumes are starting to come out. And slowly you can see like this I-beam will start disappearing as the dust plume starts to unfold. Now you can see it's really dusty. All this plume is pouring out. We're alarming. And eventually a person comes over here to check out the problem. I'll fast forward to that. But I often laugh because people think they have a dirty factory, and this is a dirty factory. But yeah, so we're detecting a dust plume on the furnace by looking at an area, and when I can't see that area because it's being covered by dust plume, I alarm and they send somebody to do something. This guy just disappears off into the mist, though. It's kind of funny. So I am gonna I think stop sharing at this point and open it up for questions.
Yeah, thanks, Kevin. What a great presentation. I'm glad it was obviously very evident. You don't want to harp, but you want to help. So
Yeah, help us. We need
yeah,
help.
yeah, for sure.
We're never getting rid of people, man. The lights out factory's not coming. It's too expensive.
Yeah, so you obviously made it very clear it's fast to deploy. It's obviously reliable for the industrial settings. It's off the shelf. Clearly, you and your company want to be a resource to everybody. So we do have some questions coming in. So those that didn't get their question, feel free to drop it in. But the last video that you just shared really sort of answers the first question that came in because it asked, can you explain, is there any light requirements in the line? With that video you just showed in Alpena, it was probably not very
Yeah,
well lit.
so
But what's yeah.
a lot of machine vision systems, they'll tell you they need special lights. And there's a lot of special light companies that sell you a LED light bank for $1,000 or more. No, I don't need special lighting. My only rule of thumb is if you can see it on a monitor and you can teach someone to detect it on a monitor, then you can teach our software to do it. If you can't see it on a monitor clearly and you couldn't teach someone because you can't see it, then you need to get some light on it, whatever kind of light that is. Now, when you get some light on it, if you can see it on the monitor, then we can detect it.
All right, thanks for that. There was obviously you talked a lot about automotive. Can you talk about some of the other industries besides
Sure.
manufacturing that you could deploy
Sure.
detected in?
We are, I concentrated on automotive manufacturing because of the town I'm in, the background I grew up in. But this technology crosses many market verticals, and we're currently being pulled into Department of Defense, again, more so for manufacturing quality assurance in the defense manufacturing base, not for, on the battlefield or anything, but for manufacturing in the DoD sector. Additionally, we are being pulled into the pharmaceutical sector for mostly the same thing. They make pills. Now, I'm not looking at the pills that they're being made. I'm looking at the people to make sure they have their gowns on, their hats on, their hair nets on, their masks on, their safety glasses on. They're not leaving empty pill bags on the floor. So the technology is being pulled across into other sectors right now. By way of people just finding us.
All right. Looks like we got another one. So for the detected software, can you talk to me a little bit about the manufacturing operator assistance?
Sure. Yeah,
Yeah.
let me actually, I'll share my screen and play a little video while we do that because it will tell the story, I think, what you're going to ask. So people want to know operator assembly. Let me pull it up here. So if I can check that the part is assembled right in station before it leaves, I also can do electronic work instructions to help train operators. So I'm using a simple $100 camera over this demonstration where I'm telling the operator how to assemble this engine. Step one, put the valve cover on, but the operator's never been trained. They just stuck the valve cover on backwards. So it told them turn the valve cover around, and it didn't give them step two. Now they're on step two. It's saying to tighten that upper right bolt, but the operator's got the torque wrench on the wrong bolt. That's not correct. So it won't, it'll check mark, now you did the right thing. Now we'll do the next step, and it won't give you the next step until I see the current step done properly. So this is where, instead of just checking the whole thing at the end to make sure it's right, which we get used a lot, we can now do work instruction step by step, which helps train people, because we have new people all the time. And eventually the operators don't even pay attention to this stuff. They just go about the motions, but it catches them when they make that mistake.
That's a good visual. Thanks for sharing. So we got another one. Do you have any situations where you integrate data with other systems, such as MES, quality management, LIMS?
All the time, every job. So every job I'm talking to usually one or two things, the PLC that's on the plant floor and the MES system that's up in the IT closet. So the MES people want data, and we provide all this rich data. So we have a REST API on top of us that we pass all of our detection data with pictures, with information, size, location, confidence, all that stuff up to their upper level business analytical systems. We also do offer some of our own packages as well, but most of my customers tie it into their existing systems.
That's good to know, obviously, because a lot of people have their own systems. So
Yep.
we have another one. You showed very high detection probabilities, 98% certainty and higher. How many images needed to be taken during training sections?
Sure. Yeah.
In order to obtain those levels?
Yep, good question. Generally speaking, we run in video. I recommend 200 frames of data on any item or label in the system that you want to train. For most applications for assembly, it's a little different for defect detection. It can be more than 200. It can be a couple thousand different variations, but I don't want the same defect, 1,000 pictures of the same defect. I'd like different defects if I'm doing defect detection. But for most assembly verification, is that thing snapped in? Is it installed correctly? Is it clipped down? 200 frames of data.
Right. What's the probability of this system? What's the portability, not probability, excuse me. What's the portability of these systems? Could it be used as a handheld camera scanner?
Yeah, I should have one on the desk, but we're down at the Automate show in Detroit where I have both of my handheld cameras down there. But basically, it's a handheld camera. It looks like about this size. It looks like a mag light flashlight. It has 1080p, 20 frames a second, Wi-Fi connection. So to me, it's the same thing as any other camera. It's just coming over the Wi-Fi link to me. I also did write an app for the Android phones, not yet on the iOS, but Androids, that I can use the camera that's on the Android phone and then hook that up through Wi-Fi to my system, so I can use your phone can actually be your camera if you had to carry it inside a car cabin. Most people don't use that. They go with the handheld Wi-Fi camera that looks like a mag light because it's more industrial.
Excellent. Thank you for that. It looks like that's wrapping up our questions today. I did put in the chat, if anybody wants to get a hold of Kevin, he can reach out. You can reach out to Addie Stone Richards, our Director of Membership at Lyft. She'd be happy to make the connection. And we appreciate your membership and your technological.
I would like to talk to my crew out there, everybody out there. I don't know if you all know Lyft in Detroit, but it is one of I think there's only 5 in the whole country advanced manufacturing materials institutes that is down on Rosa Parks Boulevard in Detroit. You all need to go see this stuff. Anybody that's been in the manufacturing business like I have and you all have, you need to go look at this technology they have at Lyft. There's stuff there that you've never seen before that could help you become more, have an advantage in manufacturing that you don't currently have, because none of the machine tool builders that are around that you use know about this stuff. So please make your way down to Lyft and take a look at it. To me, it was some of the coolest technology I've seen in manufacturing in all 40 plus years I've been in business. And I was honored that you guys accepted our membership and embraced us, because we're kind of like the advanced manufacturing AI quality system. And that's what we're doing down at Lyft as well. So make your way down to Lyft, please. You will be thoroughly thrilled.
That's really nice. Thank you for that nice compliment and plug.
No,
And
it's
again,
true.
those,
It's good stuff.
yeah, I appreciate that. And any folks that do want to stop by, please reach out to Addie, and happy to talk about membership and schedule a tour. We do appreciate that. So we're going to wrap it up today. So thank you, everybody. Thank you, Kevin, for a great
Thank you.
presentation.
It was my honor. Thank you.
Yeah,
Thank you.
excellent. Thank you for joining us. Stay tuned for obviously more webinars. Look forward to more groundbreaking projects and membership opportunities, as we said. And please mark your calendar for June 11th for our next Liftoff webinar. Our member AMT, the Association for Manufacturing Technology, is going to talk about inside the additive manufacturing landscape, tracking market, news, and investment trends. So mark your calendars. Thanks for joining me, everybody, today. Have a great day. Thank you.
Everyone, my pleasure. Enjoy. Thank you kindly.
Okay, bye.
Bye-bye.